Yeah, so this week's lesson is advanced data visualization techniques. We are in week 13. Before we dive into advanced data visualization techniques, let's do some recap of some important concepts from the previous lessons, right? Um, in the basic data visualization, you might have already worked with Matplotlib, lib, Seaborn, right, in order to visualize charts. So I just want to showcase some of the differences between Matplotlib, Seaborn, Plotly, and Streamlit. So in the today's course, basically, we will we will check about Plotly for interactive plotting. We use a Streamlit basically to build dashboards and also to build an web application for the graphs, right? So Plotly and Streamlit, two different frameworks. And we already know about Matplotlib and Seaborn in the previous lessons. So I just want to show the differences between these these four frameworks actually, right? Matplotlib and Seaborn are for basic static graphs, and Plotly is for interactive web-based plots that we'll discover in the today's lesson, like how can we create interactive plots using Plotly, right? So the matplot is highly customizable. Seaborn is for quick exploratory data analysis. As we already spoke, Plotly is for interactive dashboards and data storytelling, right? So Seaborn is built on top of Matplotlib. If you have to work with Matplotlib, you have to. It's actually low level library wherein you may not have a lot of functions which do the functionality. You have to write a lot of code if you have to work with Matplotlib because it is a low level library. With Seaborn, your code becomes smaller compared to Matplotlib, but you can achieve the same graphing with Seaborn. And Streamlit is an application layer. It is a web framework used to build data apps, right? We use Matplot, Seaborn, and Plotly for plotting graphs, but we use Streamlit to host the application as well, host these graphs, basically, right? Um, you can see over here. Plotly makes a chart. You can hover. Streamlit creates a buttons, sliders, and sidebar that allows a user to control what data the chart shows, right? Yeah.
Excuse me, I think your screen is freeze. I'm still seeing the same page. So I don't know, you are scroll the page or you're still on the CTD page.
I'm not in the CTD page.
I'm seeing only CTD page,
Oh,
advanced.
yours. Okay. Um,
Yes.
Let me see. Thanks for letting me know.
Yeah.
Stop share. Desktop 2. Okay. Okay. Are you able to
Yeah,
see?
yes, yes.
Uh,
Now I can see. Yeah, thank you.
okay. Yeah. So, so again, so Matplot is for static graphs, static images. Seaborn is also for static images. Matplot is low level where you have to write, if you have to build a graph, you have to write more number of lines of code compared to Seaborn. Seaborn is high level, built on top of Matplot. So ideally, if you have to build the same graph in Seaborn versus Matplotlib, you will write less number of codes, right? And Plotly is for interactive graphing, and Streamlit is also for interactive graphing, where you can publish the application as well. You can basically create a web application using Streamlit, right? That is the difference between these four um, libraries or frameworks. And let's go to. So can I ask a simple question? If you can explain the difference between data frame and series.
The data frame, I think it's like a column in rows structure, like in a table structure data.
Mm-hmm.
In the series, I think it's like in the arrays. I mean, like we have array in list in the programming sequence of the data.
Right, right. So yeah, so basically, series is a one-dimensional, data frame is two-dimensional. Data frame represents a table which has both rows and columns. Series represents a single column with an index. So you can think of series as like a single column. Data frame is like a table, complete table with rows and columns. So that's the primary difference between series and data frame, right? Um, and we'll go over some differences between different charts. This will be helpful for the today's lesson. So line plot, bar plot, and histogram, right? Um, so basically, line plot displays information as a series of data points connected by a straight line segment, right? Let me go over. See over here, this is a basically line plot. Um, you can, let's say you want to visualize the stock price for the day at various time instances, then you can represent that using line chart in a better way. So line chart is basically, it'll display trends over time, right? It'll display trends over time. Bar plot is for basically comparing categorical data, right? This is an example of a bar plot. Let's say you want to visualize the sales per month, then the better chart for this use case is basically a bar plot. You will take month in x-axis and count of sales on y-axis. So this is basically bar plot. So bar plot is ideal when you need to compare quantities between different categories, such as sales of different products or regions, right? And there is histogram. Let me go, let me go to this one. So histogram is similar to bar plot. You can see over here, right? So it is similar to bar plot, but whenever we have a continuous numeric data, then we use histogram, right? It looks similar to bar plot, but bars in histogram touch each other because it's a continuous numerical variable. So this is about histogram and the difference between bar plot and histogram, right? And then I want to discuss about another type of graph as well, which is a scatter plot. So we visualize the data using dots to represent the values of two different numerical variables. Let's say this is x-axis, this is y-axis. We represent value as a dot. Basically, scatter plot helps us to derive correlations, helps us to derive trends actually, right? So you can see over here, it is primarily used to see if there is a relationship or a correlation between two variables, right? The correlation is positive. If one variable increases, the other variable also increases, right? You can see over here, if x is increasing, then y is also increasing, the dots, right? So when x increased, y increased. So this is a positive correlation. Negative correlation is one when one variable increases, the other variable decreases. For example, you can see this point, x increased, but y decreased. If you see this point, x is decreased, but y increased. As x increases, y is decreasing. So this is a negative correlation. And here we are not able to derive any correlation. And scatter plot helps us to spot outliers. Let's say let's say there is a dot here. It is actually it is lying at a distance from the actual group of dots, then that is considered as an outlier, right? This is about scatter plot. Um, I think I'll stop there. If there are any questions, um, you can ask those questions, and then I'll jump into the coding part.
And no questions so far. Yeah, everything is clear.
Cool. So, so we'll see about visualizing the data directly from DataFrames today, and again the interactive plotting, building interactive apps using Streamlit, right? For this lesson, you have to create a new repository, it seems. Here are the steps to create a new repository. And when you create a new repository, you have to activate the virtual environment, right? You need to create the virtual environment, create a virtual environment, and then activate the virtual environment. And all your dependency libraries, you can include them in requirements.txt file in order to install them as a group of libraries, right? If you have to install only NumPy, you will say pip install NumPy. But if we have to install group of packages, then you include all those package names in requirements.txt and then install them at once. So for that, you use pip is a package, Python package installer. And then when you say install -r requirements.txt, all these packages will be installed. So once you install the packages, you have to link your interpreter. So you go to command palette and then you link the interpreter, right? This is something you might have done for your first assignment. or for the first lesson, but here are the steps to do again. For this assignment, you have to create a new repository, so you have to do these steps again, right? And then comes to plotting with pandas. So we talked about line plot, bar plot, histogram, right? We talked about when to use these plots already. Um, so here is the first cell. Here I have a data variable, which is a dictionary of type string and any, and I am converting the data variable to a data frame variable, and I'm trying to plot based off of the data frame. Here I'm saying keep month in the x-axis, sales and expenses in the y-axis here to the plot function, right? Um, I want a line graph, so I'm saying kind equals to line, and I'm giving a title to the graph. This is the title to the graph. Then when I say plot.show, it'll go ahead and create a line graph. Similarly, for bar graph, I'm saying month on x-axis, sales on y-axis. I require a bar graph for kind. I mentioned bar, right? And then let me run this cell. When I run this cell, you can see over here the line graph and bar graph are created, right? So this is how we use matplotlib to create line graph and bar graph, right? And now comes to plotly. So so we are importing plotly express as px, importing data as pl data. You can see over here, this is an existing data set. We are reading existing data set as a data frame, and over here I'm printing it in order for us to know what is the data in the data set. And we discussed about scatter plot just now. Creating a scatter plot here. We are saying x-axis, it should keep sepal length, for y-axis petal length, right? For color, we are telling each species should be in a different color. We provided title to the graph as well, right? And hover, what data needs to be displayed when we hover on a data point, right? And what we are doing is this figure, the scatter plot figure, we are writing it to an HTML file. And we are saying auto open true, then this HTML file will be opened in the browser automatically, right? And let me run this. So you can see over here, iris.html file is created in the folder structure. This is iris.html, and this is how the scatter plot is not sure why colors are not rendered, but it has to display the colors as well. Let me see. Let me go back. Did I made any change here? Okay, I will delete this and rerun this. Yeah, actually it'll show the colors as well. For some reason, it's not showing the colors, but when you run it, you can observe the colors as well. So um, you can see this is interactive, right? When I H over, it is displaying this extra tooltip with the information, right? And sepal length is on x-axis and petal length on y-axis. In the code, that is what we asked it to draw, and there is a title. So this is how we create interactive graphs with Plotly, right? And you can you can do zooming, panning, some gestures also work in this interactive plot. And now we'll go to Streamlit. So yeah, so for Streamlit, we are creating a Python file. We are creating a Python file actually. See, you can see over here dashboard underscore app.py is the Python file. Actually, app.py. Yeah. App.py is the Python file I created. Um, you can see over here app.py file needs to be created, and I have copy pasted this code in app.py. This code is also straightforward and simple. We are setting the title, header, subheader, again one more subheader, simple text markdown. So Streamlit, we can render the markdown format of text also. So markdown, if you don't know, markdown is a format, um, and we can directly render the markdown text with Streamlit, right? And you can see over here, right? We can give some code as well. Um, so yeah, we can pass various types of data to the Streamlit, right? And let me go to app.py, and so I'll remove this exercise 2 and 3 for now and just keep exercise 1, and I'm saving the file. Now when I run this in the terminal, in order to run this, you need to do Streamlit run app.py, the file I wanted to run. So when I run this, um, okay, I need to go to that folder. I'm not in the right folder. So our app.py is in advanced data visualization techniques folder. So I'll go to that folder and then run the command streamlit run. And yeah, you can see it opened a web application with the local host. And the data, you can see section 1, header, subheader, the code we passed in, right? So the code, you can see print hello world is the code we passed in. It rendered as a code block in the Streamlit web app, right? So yeah, so the markdown, you can see there is some formatting applied. Um, some formatting applied as per the markdown text we gave, right? So This is about displaying text and data using Streamlit. And then section 2. Section 2 talks about displaying various types of input fields, um, UI elements, various types of UI element like select box, multi-select box, date selection component, time selection component, button, etc. I will I'll copy paste that code and show you. So this is exercise 2 code we just now talked about. I'm saving it and then I'll refresh the web app. Then you can see section 2 rendered. These are all the UI components we asked Streamlit to render. Right, button is there, time selection, date selection, multiple options, slider, and input components. Right, and I will display the thought exercise. Um, Thought exercise gives more customization. I'll save it and refresh and see what customization we are getting. So section 3, yeah, this is the customizations rendered. And also you got a sidebar, right? Yeah. And you got a drop down here. So likewise, you can create a web application itself using Streamlit, right? So section 3 we talked about. So this talks about building a sample dashboard using Streamlit. So I created a new file here, dashboard underscore app.py, and copy pasted this code, right? Yeah, I copy pasted the code. Let me run, let me run it and we'll notice the output. Streamlit run dashboard underscore app.py, right? Yeah, product B, product C. Yeah, so the we'll look at the code a little bit, but so we can see using Streamlit we have created a dashboard as well, which includes the bar graph as well, right? So if you see here, there is a sample data set. We created a data frame. Then we are saying a sidebar header should be filter options. You can see. Then then we are providing some title. We are filtering out the data. We are telling how the filter should be created. We provide a title, then over here a bar chart is created and that bar chart is plotted, right? So yeah, this is another example of how we create web application using Streamlit, right? So yeah, that's about it. Yeah, here there is some text about difference between static and interactive visualizations. Static visualizations are easier to create and they're quicker to render, but obviously there is no user interaction because they are static. Interactive visualization allows user to explore the data, zoom the graph, filter the data. Basically, it provides interaction. It gives more engaging experience to the user, right? So that's about the today's lecture, or the lesson. Do you have any questions?
I have one question about the Streamlit. It's like it's in our local machine, it's fine. It will be run on our local host.
Mhm.
So if we want to deploy it to the cloud, so which technique we have to use? The same Streamlit, or there is another option for the cloud to deploy our application?
Yeah, yeah, that's something I think we have to explore. So it can be deployed. I have seen Streamlit.app in the URLs. I have seen sample apps which use Streamlit.app and it is hosted somewhere. But that should be possible. Let's see. So this is how we run it and render free tire for more control. Yeah, it should be hosted. It depends upon where we want to host. Also, that's something you can explore further. Also, I'll share the documentation
Okay,
if I find some documentation.
sounds good. Okay.
Yeah. Um,